Solving problems, section 4.7. So in this section, we're going to have both permutations and combinations and conditions. So it's really practicing all the things that we've learned. So here's something we're going to explore. There are 5 swimmers in the first heat of a race. Aubrey, Bets, Cam, Deanna, and Elena. A, B, C, D, E. How many ways can the 5 swimmers finish first, second, and third? So this one is really, how many ways can they finish first, second, and third? It's really a permutation, okay? Oops. Since this is a race and the participants are assigned a finish position, order matters. Since this is a permutation, so this is a permutation problem using 5P3. So we have 5 swimmers. How many ways can we arrange 3 of them? Okay. The second question says, how many ways can the 5 swimmers qualify for the final race if top 3 finishers qualify? So they just want to know how many ways can we group 3 of these swimmers, right? How many ways can 3 people qualify? How many? Yeah. So here we are not interested who finishes the race, like who's first, who's second, or third, but rather how many ways 3 people can be chosen from the group of 5 participants. This is combination, 5C3. 5 swimmers, how many ways can we group them into 3 or 10? Notice that permutations have more than combinations. That's a property that we know. So sometimes looking at a question and thinking, am I looking for more or less, is also going to help you solve this. Does order matter? Order matters is P. Order doesn't matter is C. Okay, so it doesn't, ABC is the same as CBA, that it's combination. We'll go through an example. So we have this band that has recorded 3 hit singles over its career. One of its hits went platinum. The band members select 15 songs, including 3 hits, for the list of their upcoming concerts. So how many sequences for the set list are they if the band wants to open with a hit, play a hit in the middle, and then end with their platinum hit? Okay, so how many different ways can they arrange those 15 songs? Okay, so does the order of the songs matter in each possible set list? And explain. Order does matter. They're creating a list of songs, so each song is associated with a different position. A different list corresponds to a different order of songs. Okay, so when order matters, it's a permutation, right? So here we have order, order mattering. B, are there conditions? Yes. Their platinum hit must be played 15th, and their other hits must occur at 1 and 8. How many platinum hit songs are there for choose from? There's only one. It's one, choose one. Okay, how many hit songs are there for the first position? Well, there's 2 to choose from. 2, choose 1. You could also think this in terms of permutation with the restriction that the first song must be one of the non-platinum. So there are 2 choices. Okay? Once they've chosen the hit song for the first, how many hit songs are there to choose from the middle? There'd only be 1. Okay? How many ways can they arrange the remaining? Sorry about that. So they're the remaining songs. So they have 15 and they've already chosen 3 of them. So they have another 12. So how many ways can they fill those 12 is what they're asking here. So that is number F. They can go 12P12. There's 479,000,000. Is that how we do that? No. Million. 479,000,001,600 ways. Amazing. 12P12, which is 12 factorial. Amazing. Okay, write the expression that represents the number of different set lists. Okay, so what we have to do is we have to take the way we can choose that first hit, the way we can choose that middle hit, the way we can choose that platinum, times 12P12, the way we can choose the other 12. As a permutation, that's how we write it. Wow. Okay, pretty neat. I would do it this first way. Okay, same answer. That's amazing. 958 million ways. Okay, did your expression in part G involve combinations? I did combinations. Did you use the fundamental counting principle? Yes. because we looked at the ways to do each, the first hit song, the second the platinum, and we multiplied them together. That is the fundamental counting principle. Suppose the band has only 2 hits and wanted to play 1 and 1 at the end. Would this increase or decrease the number? By what factor would it change? Okay, so it would actually increase, okay, because now we would have 13 factorial. So it's 13 times greater. Okay, I do want to show you this question as well. How many different 5-card hands that contain at most? So oftentimes counting problems have the word at most or at least. So it's really talking about a bunch of cases. At most 1 black cards. So we have to look at one case where there's exactly 1 and one case where there's 0. Both of these are at most 1. And then we have to look at those 2 cases. And in this case, we are going to add those 2 cases. Okay? Because there's this case plus that case. We multiply when it says how many ways can I choose this and choose that. But when there's cases, oftentimes we add. Okay, so just some things to think about. When solving counting problems, you need to determine if order plays a role. Then you know if you're doing permutation or combination. Order yes, order no. Okay, you need to know once you've established, you need to look for conditions. If there's a repetition, you need to divide. If there's multiple tasks and it's and, that it can be applied. If it's multiple tasks and it's the word or, then we don't apply, we add. This is typically found in counting problems that involve several cases. So just a couple hints for you. There's lots of good examples in the textbook as well. So if you come to a problem and you don't know what to do, flip back and look through some of the questions that are in the textbook and say, okay, is this like an example they've done? And that might guide you.